Hey fifth graders, it's Mrs. Tremblay. We are still in our adding and subtracting fractions unit, so it's unit 1. And we're talking about equivalent fractions today. Just to refresh your memory, equivalent fractions are fractions that represent the same value, or if you're looking at a diagram, they're the same size. And there's two ways to create equivalent fractions. One of those ways is by using multiplication, and the other is by using division. I know in class we spend a lot of time using our visual models. Today I'm going to kind of just get right to the point. Okay, so some of our examples we have here. I have 1/2, 3/4, 2/3, 1/9. Our job is to create an equivalent fraction, a fraction that has the same value, using multiplication. I'm going to start off and actually refer back to the diagram we looked at yesterday. Maybe it was yesterday for you. So here's 1/2. I said that equivalent fractions are the same size. They take up the same amount of space. They're equal, right? So I have a ruler here, and I'm going to set this at the end of 1/2, and I'm going to look for places on this diagram where the line ends in that same exact spot so I can see what takes up the same amount of space. And as I follow it down, the line's part way between the 1/3 and the end, so that's not going to work. But here for fourths, this line is in the same spot, and you can see that it takes 2/4 to make 1/2. I think that's kind of one of the benchmarks that we know. However, it's nice to see it here. So 2/4 is the same as 1/2. So I'm going to write 1/2 equals 2/4. Now, even though they look different, they're equivalent. They're worth the same amount. And when I say you can use multiplication to create equivalent fractions, we do that by multiplying the numerator and the denominator by the same thing. So in this case, what number would I multiply 1 by to get 2? 2. And what number would I multiply 2 by to get 4? 2. So what you really just did was you multiplied 1/2 by 2/2. And what's kind of cool is 2/2 is equal to 1. And what happens when you multiply numbers by 1? That multiplicative identity says that it doesn't change the identity of what we start with, right? So you can create equivalent fractions by multiplying the original fraction by an amount that's equal to 1, which means the digit in the numerator and denominator needs to be exactly the same, and your result will be a fraction that's equal to what you start with. So let's just try one for 3/4. We can pick any amount that we want, and let's try 3. So I'm going to take 3/4, and I'm going to multiply my numerator by 3 and my denominator by 3. 3 times 3 is 9. 4 times 3 is 12. So what I'm saying is that 3/4 is equivalent to 9/12. And if we look at this chart here, I'm going to zoom out a little bit. 3/4 is right here. When I follow it down to the 12ths, all the way down to the bottom, it ends here. So here's 3/4, follow it down, and there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. So you can actually see those are equivalent. So rather than using the chart over and over again, we can go ahead and move to that method of, all right, I'm going to multiply the numerator and denominator by the same exact thing. So if I wanted to create an equivalent fraction for 2/3, I can pick any number over top of itself. I could pick, how about 5/5? So 2 times 5 is 10. 3 times 5 is 15. That means that 2/3 and 10/15, they're equivalent. They would take up the same amount of space on the number line. Letter D, 1/9. I can multiply it by any number over itself. So how about 10? 10/10 is equivalent to 1. So this is just like taking 1/9 times 1. 1 times 10 is 10. 9 times 10 is 90. That means that 10/90ths is equivalent to 1/9. And when you think about our multiples of 10 that we've learned, yeah, those 2 zeros right there, we saw what happens. That is the same as 1/9. All right, so that's how we would use multiplication to create equivalent fractions. You can also use division. So you can create equivalent fractions by dividing the numerator and the denominator by the same amount. And the reason that works is because when you divide it by a numerator and denominator that match, it's the same as dividing by 1. And when you divide something by 1, it does not change it, right? It stays the same. So when I look at 3/9, I want to come up with a number that divides equally into both of those. I want it to come out to be a whole number amount. So when I see 3 and 9, I know that 3 goes into both 3 and 9. So I'm going to divide my numerator by 3, and 3 divided by 3 is 1. And I'm going to divide my denominator by 3. 9 divided by 3 is 3. So when we divided by this 3 over 3, it's the same thing as dividing by 1, right? So 1/3 is equivalent to 3/9. And if we look at our chart, I'm going to zoom out again a little bit. Hopefully I'm not making you dizzy. Sometimes I make myself a little bit dizzy. Here's 1/3. When I follow it down, here's the 9ths. 3/9 takes up the same amount of space as 1/3. So there's proof that it works. I'm not just making this up. I promise. All right, now I'm looking at 6 and 12, and I want to ask myself, okay, what is, and honestly, it's really good to look for the largest number that divides into both. With 6 and 12, I know that 2 goes into both 6 and 12, and so does 3, but so does 6. So we always want to look for the largest number that divides into both. So I'm going to divide both of these by 6. 6 divided by 6 is 1. 12 divided by 6 is 2. That means that 1/2 is equivalent to 6/12. It's just like dividing by 1. 6/8, the largest number that would divide evenly into 6 and 8 would be 2. So I'm going to take 6 divided by 2. That gives me 3. I'm going to take 8 divided by 2. That gives me 4. That means that 6/8 and 3/4 are equivalent. They would take up the same amount of space. Last but not least, in this example, I have 10/12. The largest number that would divide evenly into both 10 and 12 is 2. If they're both even, 2 will automatically go into both. But sometimes it's not the largest digit that will. In this case, it is. So 10 divided by 2, that's 5. 12 divided by 2, that's 6. So 5/6 is equivalent to 10/12. And that's how you can use division to create equivalent fractions. So why do we need to know that? Well, we'll need to know that when we're trying to add and subtract fractions with unlike denominators, but we also need to know that when we're trying to figure out a value that would make two fractions equivalent. So if we look down here, it says apply it. Multiply or divide to calculate the value of the variable that makes each pair of fractions equivalent. So basically all this is saying is, what does this variable n have to be in order to make 2/3 and n over 6 equivalent to one another? Well, we said that we can create equivalent fractions by multiplying the top and bottom by the same digit or by dividing the top and bottom by the same digit. So when I look here, I see that, okay, across from the 2, I don't know what n is, so that's not really going to help me. But down here, I have a 3 and I have a 6. So I can ask myself, what did I, and I'm going from a smaller digit to a larger, so that means multiplication here. What would I multiply 3 by to get 6? Well, 3 times 2 is 6. And we said that we create equivalent fractions by multiplying the top and bottom by the same digit. So if I have to multiply 3 times 2 to get 6, that means in order to find n, I can take 2 times the same amount I multiplied the bottom by. So 2 times 2 is 4. That means that n equals 4. So 2/3 and 4/6 are equivalent. And looking at J, here I see that I have a 20, I have a 5, I have a 32, I have a Y. I'm going to look at the top because both of those digits are there. And this time I'm going from a larger digit to a smaller digit, a higher value to a lower value. So that's going to take some division. So I can ask myself, 20 divided by what is 5? Or I could go backwards and ask myself, 5 times what is 20? Either way, I'm going to look at it and it's 4, right? So 20 divided by 4 is 5. That means in order to create an equivalent fraction, I need to divide the bottom by the same exact thing. And 32 divided by 4 is 8. That means that y is equal to 8. Right, look at letter K. And if you wanted to pause right here and you wanted to try some of these examples on your own, it would be a great time to do that. Letter K, I have m over 4 equals 9 over 12, and I want to know, okay, what does m need to be in order for these to be equivalent? and I see that I'm going to have to use my denominators to help me out. I'm going from 4 to 12. Would I use multiplication or division to get from 4 to 12? Multiplication. 4 times what is 12? 4 times 3 is 12. Now this one's a little tricky because up here I want to do m times 3 is 9, right? But I don't know what m is. So we can use our backwards relationship here. If 4 times 3 is 12, that would mean that 12 divided by 3 was 4. So I can go ahead and divide 9 by 3 to get m. And 9 divided by 3 is 3. And that means that m is 3. And I can double check that and ask myself, is 3 times 3 9? Yes. Is 9 divided by 3 3? Yes. It's that forward-backward relationship, that inverse relationship that we learned way back when in 3rd grade when it all started. All right, we're on L. And I see a 7, I see 28. So my numerators are both given. There's not a variable in the place. I'm going to ask myself, okay, what do I do with this 7 to get 28? I can do 7 times 4 to get 28. I could also do 28 divided by 4 to get 7. I'm going to need that because here I have to go backwards. So if 7 times 4 is 28, that means 28 divided by 4 is 7. So I'm going to need to do 40 divided by 4 to get C. And 40 divided by 4, you guessed it, is 10. So C is equal to 10. 10 times 4 is 40. All right, letter M. I have 14 and then I have a W, so that's not going to help me. But here I have 35 and 5. So what can I do to 35 to get 5? 35 divided by 7 equals 5. And I can go ahead and divide 14 by 7 to get 2. So that means that 14 over 35 is equivalent to 2/5. And last but not least, letter N. If 4/4 equals 16 over n. Now maybe some of you are looking at this and you're like, well, it's 16 because 4/4 equals 1, and I'd have to put 16 over top itself to make that equal 1. So if you looked right at that and you automatically knew it was 16, that is A-okay. If you're looking at this and you're like, well, I'm going to use the same strategies we've been using, and 4 times 4 is 16, so I'm going to multiply the bottom by the same thing. 4 times 4, also 16, so that means n equals 16. All right, after this, I would like you to go and try the questions I have set for you. Good luck. Miss you.